Today we are going over graphing functions and how to figure out what the rate of change is from a graph, and then we will look at tables also. The rate of change describes how one quantity changes compared to another. So when we are going to look at these graphs, we're going to have to figure out what the rate of change is. Now, on proportional graphs, always pass through the origin. So if a graph is proportional, it will go through the origin. Okay, always pass through the origin. Right here, very important stuff, okay? So if I'm looking at a graph that does not pass through the origin, it is not proportional. Proportional graphs. Also, the rate of change, or we can call that the constant of proportionality. I'm talking about the same thing. Rate of change, constant of proportionality, I mean the same thing. That can be found from a graph by finding an ordered pair and then finding the ratio of y over x. So another way to write that is, get a pen here. So y over x. And k is what I'm going to call that rate of change. So k is going to be y over x. K is the change. Later you will learn that k, I can use the letter m, but right now we're just going to use the letter k. The equation to represent a proportional relationship is y equals kx. So y equals kx. And what does that really mean? That means y equals k times x. Okay? Y equals kx. K being the rate of change. So where k is the rate of change or constant of proportionality. So what is k in that? It is the rate of change. It is the difference, what is changing from one spot to the next. Okay, so let's look at this example here. So the graph shows the rate that a monarch butterfly is traveling during migration. So where am I going to get these x and y values from? Look at this graph. And when you look at this graph, okay, these are positive here and this is positive here. This is just quadrant 1 of a coordinate plane. Okay, here is the origin right here at 0, 0. This, however, they cut that graph down to just show us quadrant 1. So I am looking for the rate that a monarch butterfly is traveling during migration. So I know to find the rate, okay, I know k equals y over x. I know that this right here is my x-axis. This vertical line up and down is my y-axis. Always, okay, if they are showing me quadrant 1, well, I'm going to make it a different color. Let's go y, we'll call it blue. Now, looking at the information, let's find a point. Here's the line. So any of the points on this line is true. That's what it's saying, but I need to figure out what the rate of change is. So I want to look at this line, and I want to find a spot where it crosses at a little x. Okay, so I can know exactly this crosses right here. So I'm going to pick this spot right here. And if I take and draw a line straight down, I see I have a x value of 2. If I draw a line straight over, I have a y value of 10. Something to pay attention to. This goes up by 1 every time on my x, but my y value skips by 5. So back to the point that we picked. Right here, we picked that point. So we said we have a y value of 10. We said 10 over a x value of 2. Now I know I need to simplify. 2 goes into 10. I can do this and come out with a whole number. 2 goes into 10 5 times. So my rate of change is 5. Now if my rate of change is 5, so k equals 5. In order to write an equation, because I need to write an equation, so I know I have that y equals kx. Now, all I have to do is take that 5 and input it for k. So to write an equation is y equals 5x, which really means 5 times x. How does that look now when I do the math? So let's take something like 4 as an x value, right? If I put 4 in for x, so 4 in, so I'm going to have 5 times 4. 5 times 4 equals 20. So my y value would be 20 if my x value is 4. Now let's see if my x value being 4. Okay, go up here. And then I will go over to where my y value is 20. So this equation is true. Maria is baking chocolate chip cookies. Each cookie has 9 chocolate chips in them. Create a graph to represent this situation and find the rate of change and equation. So first thing is I probably should highlight the information I know and what I'm looking for. So I know that each cookie has 9 chocolate chips in them. Okay, so every cookie has 9 chocolate chips. I know this. What am I looking for? I need to create a graph that represents it. I need to find the rate of change, and I need to find an equation. So I have 3 things I have to do. I can't do one part and move on. That is not answering the question. Okay, rate of change. So I know each cookie has 9 chocolate chips in them. Well, on my x-axis, I have cookies. So for the rate of change, so the rate of change is going to be 9 because every cookie is going to have 9 chocolate chips. So if I want to figure out how many chocolate chips I need, I take that and times that by the amount of cookies. So chocolate chips is going to be my y. Now the equation. I know the form for writing a proportional equation is y equals k times x. K being the rate of change. So I just write this in. Y equals 9x or 9 times x. Now I can go ahead and create this information and figure it out. I can even go ahead and create a table, right? So table, I'm going to call x and y here. I know my x is cookies and my y is chocolate chips. So if I had 1 cookie, how many chocolate chips? Well, let's figure this out. Take x value of 1, put it into the equation. So y, I don't know what that is yet, it equals 9 times 1. 9 times 1 is 9. So y is going to be, so 9 times 1 is 9. Here, that'll give me 9. Y equals 9. So when x is 1, y is 9. What about 2? when x is 2? Well, y equals 9 parentheses 2. I put the parentheses around where the x was just to say because I inserted 2 into the problem. So 9 times 2 gives me 18. Y equals 18. So I can plot that. Down here, find number of cookies. So 1, I go up to 9. Plot it. Go over to 2 cookies. Well, 2, I'm going to have 18. Goes here. Plot it. Need at least 3 points to go ahead and graph a line. So I got 2, I'm getting close, but let's pick something a little bit farther out. So let's go, how about 5 cookies? If I make 5 cookies, how many chocolate chips will I need? Well, y equals 9 times 5. 9 times 5 gives me 45. Y equals 45. So if I have 5 cookies, I'm going to be on the 5 line, go up till it's 45 on the Y. And now I've got 3 points. Well, I've got 3 points, and I can go ahead and graph my line. Okay, rate of change for my table. I've got a table right here. I got Y and X. Well, we know that the rate of change is K, and K equals Y over X. Well, I already have a table. I already have X value, I already have a Y value. So pick 2 coordinates, pick a group, set it up, make sure you put the Y over X, so it's 14 over 2. 14 over 2, if I look at that, I can simplify that. I simplify that to 2 goes into 14 7 times, so K equals 7. So my rate of change is 7. Now, if I know my rate of change is 7, I know the equation that I want to use is Y equals K times X. Take 7, put it in the equation instead of K. Y equals 7X. Same with looking at number 2 here, okay? I need to find the rate of change. Rate of change, if I hear that, it is going to be K. K equals Y over X. Well, I have some coordinates. It does not matter. I could have picked these ones, these ones, these ones. Does not matter. If it's proportional, it'll work out the same every time. They will simplify to the same number. So set it up. K equals 6 over 9. And can I simplify that? Looking at both those numbers, I know they are multiple of 3. So 6 divided by 3 will give me 2. 9 divided by 3 will give me 3. 2/3. So K equals 2/3. Leave it in a fraction form for right now. Unless they ask for it in decimal, leave it in fraction. So the rate of change is 2/3. Now the equation. Again, I know Y equals K times X. So the equation would be Y equals, insert the rate of change, because I figured it out, that is our K. K, so 2/3 times X, or 2/3 X.